Hello everyone, and welcome to the first video on data interpretation. We will, in the first few videos, learn some basic calculation techniques which would enable you to do calculations much faster. In DI, you need to do a lot of calculations, so it makes sense that before moving to the concepts of DI questions, we should first study faster calculation concepts. Most of the concepts that we will learn in these videos is a part of Vedic mathematics. So in this video, we will start our study of Vedic mathematics by learning two concepts, base and complements. So let's start with base. You may know that our number system, also called the decimal number system, is of base 10. Similarly, binary number system has base 2, octal, which was used in older computers, has base 8, and hexadecimal, which is used in computer engineering, has base 16. Now what does this mean? Take our number system, the decimal number system, which has a base 10. This means that all the numbers in this number system can be formed by using only 10 digits. These 10 digits obviously are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Similarly, in a binary number system, we can represent all the numbers using only 2 digits, 0 and 1. In the octal system, we represent all the numbers using 8 digits, which are 0, 1, 2, 3, 4, 5, 6 and 7. And finally, in hexadecimal system, we can represent all numbers by using 16 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. Now for this entire course of faster calculations, we will be only dealing with the decimal number system. So our base will always be equal to 10. In Vedic maths, we will define bases in a slightly different way. We will call numbers like 10, 100, 1000 and so on as bases. Hence, base numbers are the first number for those many digits. For example, 10 is the first number for 2-digit numbers, right? 10 is the first 2-digit number, so 10 is a base. Likewise, 100 is the first 3-digit number, so 100 is also a base. Let's move on to complements now. Those two numbers, which when added with each other result in the nearest base, are called complements of each other. For example, 45 and 55 are complements of each other as their sum results in the nearest base, that is 100. So, to find the complement of a number, we subtract that number from its nearest base. For example, let's find the complement of 23. Now the nearest base to 23 is 100. So we subtract 23 from 100 to get 77. Hence complement of 23 is 77. Similarly, complement of 41 is 59 as 100 minus 41 is 59. Now such small calculations are obviously very easy to perform. However, if we need to find the complement of a number, let's say 245, 7845, then we have to subtract it from 1 followed by 7 zeros, right? Now such a subtraction is obviously time consuming. So let me provide you with a shortcut. This formula is called all from 9 and last from 10. To elaborate, the way it works is that to find a complement of any number, subtract all the digits from 9 and the last digit from 10. Now what do we mean by the last digit? The last digit means the rightmost non-zero digit, whether the number has a decimal point or not. Now the term non-zero is very important here. In case our rightmost digit is 0, we ignore that 0 and start moving leftwards till we encounter a non-zero digit. And the first such non-zero digit will be our last digit. For example, in 32589, the rightmost non-zero digit is 9, so our last digit is 9 here. And similarly, in 327.854, 4 is the rightmost non-zero digit, so 4 is our last digit. But in 36400, the rightmost digit is 0, so we start moving leftwards till we encounter a non-zero digit. Hence, the last digit for our purpose is 4 and not 0, because 4 is the rightmost non-zero digit. Similarly, in 745.00200, our last digit is 2, as we ignore all the zeros to the right of 2. Now let's do a few examples on this. Find the complement of the following numbers. Let's start with the first one, that is 201258. Now remember our formula of all from 9 and last from 10. 9 minus 2 gives us 7, 9 minus 0 gives us 9, 9 minus 1 gives us 8, 9 minus 2 gives us 7, 9 minus 5 gives us 4, and 10 minus 8 gives us 2. Remember, we subtract the rightmost non-zero digit by 10. That's why we have performed 10 minus 8. So our answer is 798742. Let's find the complement of 34800. Now, as the rightmost digit is 0, we write the zeros as it is, and we keep on moving leftwards till we encounter a non-zero digit. Then we can apply our rule, all from 9 and last from 10. Therefore, we will apply our rule only for 348. Now 9 minus 3 gives us 6, 9 minus 4 is 5, and 10 minus 8 is 2, as 8 is the rightmost non-zero digit. So we get 652, and we carry the two zeros as it is to get the answer as 65200. So the complement of 34800 is 65200. Now let's find the complement of 428.23. If a number has decimal point, we need to follow the same procedure. The only thing to be careful about is that we should remember to place the decimal point in the correct position. Hence, we do 9 minus 4, 9 minus 2, 9 minus 8, 9 minus 2, and 10 minus 3, as 3 is the rightmost non-zero digit. So we get 57177. Finally, we place the decimal at the right place, which gives us the answer as 571.77. So by learning to compute complements, we have effectively learned how to subtract any number from its base. We can also extend this analysis to subtract a number from a higher base. For example, say we have to subtract 23 from 1000. Then in that case, simply add 1 0 to the left of 23. Now 023 is obviously equal to 23, right? So we have not changed the value of 23. But we have made it a 3-digit number. Now we can do what we have learned. Let's find the complement of 023. 9 minus 0 gives us 9. 9 minus 2 gives us 7. And as the rightmost non-zero digit is 3, 10 minus 3 gives us 7. So the answer is 977. Let's do one more example. Say we have to calculate 1000 minus 41.2314. Now the nearest base to 41 is 100, but we need to subtract it from 1000 here, right? So what we'll do is, we'll add a 0 to the left of 41.2314. So we write 41.2314 as 041.2314. Now we follow the same process. So we do 9 minus 0, 9 minus 4, 9 minus 1, 9 minus 2, 9 minus 3, 9 minus 1, and 10 minus 4 to get the answer as 928.7686. And how about if we need to subtract numbers from multiples of bases? Let's say 500, 2000 or any other multiple of a base. Such a question can be easily done by splitting the multiple of the base to the nearest base. For example, 500 can be written as 400 plus 100, 2000 can be written as 1000 plus 1000, and so on. Let's do some examples on this to understand it better. Now let's start with the first one. Let's find 600 minus 73. 600 can be written as 500 plus 100. So 600 minus 73 is equal to 500 plus 100 minus 73, which is equal to 500 plus complement of 73, which is 27. 500 plus 27 is obviously 527. Let's move on to the next one. Let's find 7000 minus 248. Now 7000 minus 248 can be written as 6000 plus 1000 minus 248, which is equal to 6000 plus complement of 248. Complement of 248 is obviously 752. So the answer is 6000 plus 752, which is equal to 6752. Now from the above two examples, a pattern can be seen. And what is that pattern? In order to do such subtractions, first make the number of digits in the number to be subtracted equal to the number of zeros in the base. In both our examples, the number of digits to be subtracted were already equal to the number of zeros. If they were not, we would have added zeros to the left of the numbers. And after that, simply reduce 1 from the multiple of the base and write the complement of the number to be subtracted. For example, in our first case, let's subtract 1 from 6. The multiple of the base is 6, right? So let's subtract 1 from 6, which gives us 5, and the complement of 73 gives us 27. So the answer is 527. In our second example, that is 7000 minus 248, let's subtract 1 from 7, which gives us 6, and the complement of 248 is 752. So we get 6752 as the final answer. Let's do one more example on this. Let's find 50,000 minus 853. Now, first, we need to make the number of digits of 853 equal to the number of zeros in 50,000. 50,000 has 4 zeros. So let's add 1 zero to the left of 853, which gives us 0853. Now reduce 1 from the multiple of the base. That is, reduce 1 from 5 to get 4. And this should be followed by the complement of 0853. The complement of 0853 is 9147. So our answer is 49147. But what if both the numbers have same number of digits? Like 8000 minus 2645. In such a case, subtract the digits on the leftmost side of both the numbers and reduce it by 1. That is, find 8 minus 2 to get 6 and reduce it by 1 to get 5. Then take the complement of the other digits of the number to be subtracted. The remaining digits of 2645 are 645 and the complement of 645 is 355. So the answer is 5355. Let's do one more example. Let's find 50,000 minus 21,378. Now first subtract 2 from 5, which gives us 3. Then reduce it by 1 to get 2. And then find the complement of 1378. The complement of 1378 is 8622. Hence our answer is 28622. Now remember, most of the steps shown above should be done mentally. Writing anything down takes time. So the more calculation you can do mentally, the faster your calculation speed will become. Now let me wrap up this session here. In the next video, we will learn how to multiply any number with 9, 99, 999 and so on. You get the idea. So see you then.